In this video, we will speak about conservation and non-conservation of mechanical energy. But before starting with this concept, we will speak about the type of forces. We have two types of forces: conservative forces and non-conservative forces. What we mean by conservative forces and non-conservative forces. Conservative forces, any force that convert energy from kinetic to potential and vice versa, from potential to kinetic, we call this force conservative. That will conserve the energy as mechanical energy. Example of this force is the weight, mg, and sometimes the tension. Non-conservative force are forces that convert energy to other form of energies. If we have mechanical energy, and for example, we convert the mechanical energy into thermal energy, then this force that converts such energy, mechanical energy, into thermal is a non-conservative forces. So, example for these forces, we have friction. Friction will take mechanical energy and convert it into thermal energy. Then it is a non-conservative force. What else? A resistance. Also, it will convert mechanical energy into thermal energy, and it is a non-conservative force. Also, traction of engine. This force will convert chemical energy into mechanical. For that, traction of the engine or traction force is a non-conservative force. It will increase the mechanical energy, and the mechanical energy is not conserved anymore. Also, another example is the muscular forces. Muscular forces will convert also chemical energy into mechanical, or it will reduce the mechanical energy and work as resistive forces. So we can reduce the motion of any object using our muscles, so the mechanical energy will decrease. So for that, all muscular forces are non-conservative forces. And we also have the normal reaction. Normal reaction also is a non-conservative force. Why? Since any time an object hit the ground, kinetic energy into zero without changing it into gravitational potential energy. So we convert mechanical energy into heat energy, into sound energy, into deformation of shape of the object. So it is a non-conservative force. Conservation of mechanical energy. While we are dealing with conservative forces, same as weight or tension, mechanical energy is conserved. What we mean by mechanical energy is conserved. Mechanical energy is conserved and it's constant. And mechanical energy at any time is constant. Mechanical energy 1 equal mechanical energy 2. We know that mechanical energy 1 equal kinetic 1 plus potential energy 1, and mechanical energy 2 equal kinetic 2 plus potential energy 2. By the way, we should know that kinetic energy 1, it is not equal to kinetic energy 2. We mean by mechanical energy is conserved that the sum of kinetic and potential always should be constant. So if we rearrange here the kinetic and potential, we can write kinetic energy 2 minus kinetic energy 1 equal potential energy 1 minus potential energy 2. So here final minus initial يعني delta kinetic energy, while here initial minus final we mean by minus delta potential energy. So whenever the kinetic energy of the system is increasing, the potential energy of the system should decrease. So always kinetic, the variation of kinetic and the variation of potential are opposite in sign. So kinetic is increasing, potential will decrease, potential is increasing, kinetic will decrease. Now, one, we have mechanical energy is not conserved, non-conservation of mechanical energy. Of course, while we are dealing with non-conservative forces, as we said before, friction, resistance, traction force of the engine, and all muscular forces, then the mechanical energy is not conserved. Why it's not conserved? Since, as we said, the non-conservative force will take mechanical energy and convert it into another form of energy, or the non-conservative force will take energy from other forms of energy and convert it into mechanical energy. So mechanical energy, it can be decreasing or increasing, but it is no more constant or conserved. So delta mechanical energy equal work done by non-conservative forces. Since the non-conservative forces are the reason of the mechanical energy not conserved anymore, so the work done by these forces, non-conservative forces, equal to the variation of mechanical energy. Now, delta mechanical energy no more equal to zero, since they are not constant, equal to work done by non-conservative forces. As much as we have in the system non-conservative forces, we will add them all. Okay. For example, if we have only friction, then we will write delta mechanical energy equal to the work done by friction. And this formula we use it only while mechanical energy is not conserved. This animation, this man is sliding up and down and reaching the same height. Here we are saying that mechanical energy is conserved. Mechanical energy is conserved. If we can see here the graph of the energies, bar graph of the energy, here the kinetic energy 0 when the man stops, and the gravitational potential energy becomes 0 when it reaches the reference. I will move it again. Okay, kinetic energy 0, potential is maximum. Potential 0, kinetic is maximum. But whenever we add these two energies, we get a total energy constant. The total energy is conserved, which we call it now here mechanical energy. Mechanical energy is conserved, kinetic plus potential. The sum of these two is conserved. Mechanical energy is conserved since no non-conservative forces or the sum of the work done by non-conservative forces equal to 0. If we add friction to our track. What will happen? I add friction. Now here the boy will stop. Okay, why the boy stops? The boy stops because the mechanical energy was converted into heat energy by the friction on the track. We can see the bar graph. Then all the mechanical energy was converted to what? To thermal energy. I can repeat the animation a little bit. Look, this is the kinetic energy is decreasing, decreasing, decreasing till potential and kinetic are minimal, and the energy converted to thermal energy. Because we have a non-conservative force here, mechanical energy is no longer conserved. Nice example for conservative and non-conservative mechanical energy. So we apply a traction force to the trolley to go up the track to the highest point. So here, as we saw, that the mechanical energy increased to a maximum value. But all that was what? Gravitational potential energy. So at the beginning, while the trolley going up the hill, mechanical energy was not conserved since the traction force giving us mechanical energy. So our mechanical energy was increasing. I can play it again. Look, has the mechanical energy is increasing, 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 increasing till it reaches to a maximum value. So now we leave the trolley sliding alone. Okay, we will suppose that no friction all over the track, no friction all over the track. So we can see that the kinetic and gravitational, okay, we are changing kinetic into potential, potential into kinetic, and vice versa, till we reach to the end of our track. Here, till we reach to the end of our track. Look, here mechanical energy is conserved, always changing into kinetic to potential, potential into kinetic. Now we apply brake. At the end, we apply a brake to the trolley. We want to stop the trolley. Then mechanical energy here is not conserved and the mechanical energy becomes zero. Why? Since the brake change mechanical energy into thermal energy and no longer mechanical energy is conserved. Application. A block considered as a particle of mass 2 kg is released from rest from the top A of an inclined plane making an angle 20 degrees with the horizontal. Take the horizontal plane containing point B as a reference level for gravitational potential energy. أعطونا ال AB equal 3 meters والgravity 9.8. Determine the speed of the block as it reaches the point B if the block is not submitted to friction force. يعني بدنا نلاقي velocity of the block when it reaches B وما عندي friction. So if we don't have friction, so no non-conservative forces, so mechanical energy is conserved. Or the sum of the work done by non-conservative forces equal to zero. And this sentence is better since we have normal reaction here and it is a non-conservative force. The sum of the work done by non-conservative forces within the system is zero, so mechanical energy is conserved. So mechanical energy at A equal mechanical energy at B. Okay, I will put mechanical energy at A. It is kinetic at A plus gravitational potential at A and equal to kinetic energy at B plus gravitational potential energy at B. Kinetic at A is zero. Kinetic energy at A is zero since at A we release the block without initial velocity. So this one is zero. And gravitational potential energy at B is zero. Why? Because the reference of gravitational potential energy, we take it at B. Then the height of B is zero. So instead of kinetic energy at A, it is zero. Gravitational potential energy at B is zero since it's at reference. So gravitational potential energy at A is mgha and kinetic energy at B is half mvb square. We need VB, but HA, we can calculate HA. It's the height at point A. It's the height at point A, and this is the height at point A here. This is the height I need to calculate. This is my height A. As we know, height A is opposite to the alpha, 20 degree. So we will use sine. Sine is opposite over hypotenuse. Hypotenuse is AB. I have AB. So the opposite is hypotenuse times sine 20. So for that here, they wrote, instead of HA, AB sine 20. Okay, VB equal 2 times mass times gravity times the height over the mass. We cancel the mass with each other. And we remove the square to the velocity, we add square root, then it is 2gha, 2 times g times ha, هي hypotenuse times sine, hypotenuse AB times sine 20, then we get 4.5 meter per second. Now the block is submitted to a constant friction force of magnitude 2 Newton. Now صار عندي friction. إذا صار عندي friction يعني I have non-conservative forces. If I have non-conservative force, thus mechanical energy is no longer conserved. So mechanical energy is not conserved. I will use delta mechanical energy equal to work done by non-conservative forces. So the friction and the normal force are non-conservative forces acting within the system. Then delta mechanical energy from A to B between A and B equal to the work done by non-conservative forces, work done by friction plus work done by normal. As we said before, work done by the normal is zero since cosine 90 equal to zero. So work done by n equal to 0 since n is perpendicular to the displacement يعني عاملي angle 90 ونحن بنعرف ال work done by a force is the force times displacement times cosine the angle between the force and displacement. So cosine 90 is 0. So mechanical energy, delta mechanical energy and mechanical energy B minus mechanical energy A equal للwork done by friction. Work done by friction is friction times displacement times cosine 180 لأن الأنجل بين الفريكشن وبين الدisplacement is 180. This is my friction. So if this is the friction and the displacement is AB, this is my displacement, AB, here the displacement. So what's the angle between the friction and the displacement is 180, since they are opposite to each other. So cosine 180 minus 1, for that they wrote minus friction times AB. Okay, so instead of mechanical energy at B, kinetic energy B plus gravitational potential energy B minus mechanical energy A, kinetic A, and gravitational potential energy A. Gravitational at B is 0. Kinetic energy at A is 0. We're left by Gravitational energy 0 since the block is at the reference. Kinetic at A since the block starts from rest. So kinetic energy B minus gravitational potential at A. I need to calculate the velocity at B. Height A, we know the height A, as we mentioned before, AB sine 20 equal to minus F times AB. AB, we know it, and friction also, we know it. We plug the numbers and we will get VB equal 3.8 meter per second. Thank you.